Hey everyone, today we're going to be talking about this worksheet covering our kinematics, our linear motion questions. And the first thing I'm going to do is just scan the page through so that you get an idea of all the different solutions and the answers. Some of the answers are listed here to the side and some of them are not, some of these two-part questions. So for the example here at number 3, the answer to number A, letter A, is this minus 4.92 meters per second squared. The answer to letter B is 61.5 meters. So I'm just going to scroll through this whole page so that you can have all the answers if you are trying to solve these worksheets and you're finding yourself a little bit frustrated. Okay, there we go. Now I'm going to turn this around. Actually, I'm going to go upside down. That is our secret word for the day, is upside down. So there's the next, here's the back side of the paperwork there. There's your answers, 2 meters per second squared for that one. There's your answers down the way there, 1.8 kilometers, 36 seconds. That's your answer there. Then you have 200 meters per second, and then finally on down 1800 meters, and 4 times 10 to the 6 meters per second squared. So that's all the solutions. We'll go back and do some of the explanations now. Starting on the first page, here's a lovely Fanta drink, and that is not the secret word of the day, but some people are going to think that it is, but that's not the secret word of the day. Okay, so let's get started. Remember, this is primarily an exercise in finding the different pieces and in finding the solution set or the formula that fits all the pieces. So in this first one, we have an acceleration of 50 meters per second squared. We have a car asking how long it would take, so we're searching for time. And then we have it in a final velocity of 24.6 meters per second. Remember, the car is starting from rest, so we have an initial velocity of 0. So we plug that into a formula. We say, which one does it have, which formula do we have that looks at final velocity, initial velocity, acceleration, and time? And we know that we have V final is equal to V initial plus A times T. So now it's just a matter of plugging in the numbers. We have the 24.6. We know that our V initial was 0. We have an acceleration. Now we're solving for time, so we're just dividing 24.6 by the 50. We get 4.92. On the next one, we are looking for the time difference. So we're given 2 starting velocities. We're given a distance. So from that we can find the time, how long it would take to go the 86 miles would be 1.56 hours. How long would it take to go the 86 miles if we were doing 75 miles per hour? Remember, that's our velocity. We get 1.14 hours. Then we take the difference, we get the 0.42 hours. For the next one, we have our initial velocity of 24.6. We have our final velocity of 0. We have our time. So which of these formulas do we look at that looks at distance, velocity, and time? So we know that distance is going to be our average velocity divided by 2, which is going to give us our time. This one, it says, is what rate is the car accelerating? Well, we know that acceleration is V final minus V initial divided by the time change. And remember, it's in the negative direction because we are braking, we're slowing down. So we have a negative acceleration or deceleration. Okay, so for the number 4, we have our initial velocity was 200 meters per second. We have acceleration, 23.4 meters per second squared. We have a time of 20 seconds. We're trying to find out what is going to be our final velocity. What formulas do we look at that have velocity, acceleration, and time? This one. V final is V initial plus acceleration times time. Plug in the values. We get 662 meters per second. So to find what Mach speed that is, we look at the ratio. We know that the ratio is 331 compared to the value. So we divide the 662 by 331 and we get Mach 2 for the answer. All right, down here we have a V initial of the bullet is 0. We know it's traveling 600 meters per second when it leaves the barrel. We know the distance. We're trying to find the acceleration. So we use this formula, V final squared. We have a V initial. We have an acceleration. We're solving for distance. Plug in your numbers. You get 360,000 is equal to 1.6 times D. You divide the two together, you get 225,000 meters per second squared. So this is just a matter of filling in, identifying what you have, what you are looking for, and solving the problems. This number 7 is maybe a little bit more complicated, so we'll look at that. Once again, we have an initial velocity of 0. We have a final velocity of 360 kilometers per hour. We know that the plane can accelerate at 3.6 times 10 to the 4th kilometers per hour squared, so fast acceleration. First thing we need to do is find out what's the distance the runway needs to be. Well, we know a final velocity. We know our initial velocity was 0. 2 times acceleration times distance. We know acceleration. So we square that and we get 1.296. And that's going to be equal to 7.2 times the acceleration and the distance. You divide the two and you get the total distance needed for the runway. Now we take that distance and we plug it into the formula, initial plus final divided by 2. Now remember, your first answer you're going to get is 0.01 hours. Well, they don't want hours, you want seconds. So what fraction, or what do you need to convert an hour into seconds? It's 3,600 seconds. So 0.01 times 3,600 will give you the 36 seconds. The rest of them are pretty much the same for number 8 and number 9. Figure out what you've got. Plug in the numbers. You've got initial velocity. You've got final velocities. You've got accelerations and times. Look at the formulas. This one you have initial velocity times time and 1/2 AT squared. Plug in the numbers, you're going to get the 1750. And there's the rest of the solutions as well. So it's just a matter of reading through the stuff, writing down what you are reading as you get them, write down your variables, find a formula, plug it in, and you're good to go. Have a great spring break.